Hello everyone, I Professor Neha Dikshit going to explain you in this video some destructive and non-destructive testing. First of all, what is destructive testing? During testing material gets damaged due to which cannot be reused again, then that type of testing is known as the destructive testing. Now, which are the destructive testings? Tensile test, compression test, hardness test, cupping test, impact test, creep test, fatigue test, bend test, etc. And these tests are included in your syllabus. Now, non-destructive testing. During testing, metal component is not damaged or destroyed and can be used for its specific application again, then that type of testings are known as the non-destructive testing. Now, why destructive testing is so important? Important for ensuring a safe, high quality material and avoiding the major liabilities associated with providing non-compliant products, due to which end consumer like us will get satisfied because of reduction in chances of a failure in. Why metals or materials are tested? We already seen the destructive type of testing and non-destructive type of testing. In destructive type of testing, material or metal can get damage, while non-destructive testing, material cannot get damage. Now, why these non-destructive and destructive testings are important and why metals or materials are tested? To check surface or defects in the raw material or process components, to determine suitability of metal or material for a particular application, for study of failure analysis, to assess the fundamental mechanical properties, for research. Now, in this video, I am going to explain you tensile test. Now, purpose of this test is, this test provide data on strength and ductility of metals under uniaxial tensile forces. Tensile strength is the ability to withstand tensile load without failure, while ductility, it is the measure of a material ability to deform under tensile stresses. So, principle of tensile test is, when metallic sample is subjected for gradually increasing stress or load which is uniaxial but in opposite direction, the sample gets first elastically and then plastically deformed and finally fractures into two. So, first of all, before going to the procedure of the tensile test, we will see standard and non-standard specimens of tensile test. Tensile test can be carried out on standard or non-standard metallic sample. Generally, specimen has a circular or rectangular or square cross section as well. Test can also be carried out on non-standard specimen, mainly applied to the steel used in construction purposes, particularly known as a construction steel. See here in this diagram, round cross section specimen and square cross section specimen is there. Some radius we already known for that specimen, cross sectional area also. Suppose round cross section is there, then pi by 4 r square, and square is then r square. Gauge length and minimum parallel length you also know, and you have to measure that gauge length and minimum total length before going to test for this specimen. Now, we already seen in previous figure, that is the gauge length and total length. So, what is the gauge length and importance of gauge length in tensile test? See here, in this diagram we already see here the gauge length, this, and distance between shoulders is total length, and distance between the one end to another end is overall length. During tensile test, all the stresses applied are get concentrated within the gauge length. Required failure should occur within this gauge length. So, it is important to note down the gauge length before the test and after the test, because all stresses applied in during this test is concentrated in this gauge length. So, obviously failure should occur within that gauge length. According to ASTM, gauge length should be 4 times the diameter of specimen. Suppose diameter of specimen is 10 mm, then according to ASTM, the gauge length should be equal to 40, that is 4 times of the diameter, or it should be greater than the 4 times. Deformation in specimen occurs is measured by instrument known as the extensometer. This is the tensile test apparatus. Now we will see procedure. Metallic specimen is gripped firmly at the opposite end and then pulled uniaxially in opposite direction. This specimen, this metallic specimen is pulled uniaxially till it gets fractured. Now you know the gauge length you already measured before the test, and after the test that gauge length is get increases because opposite direction uniaxial tensile load is applied on that bar, so that it get elongates, and that elongation is measured with the extensometer. Specimen elongates in direction of applied load and then fracture into two pieces. So effect of variables on tensile test: cold working and hot working. Suppose cold work metal is there, then it is less ductile, and hot work metal is there, then it is more ductile. While gauge length, if you decrease the gauge length, then percentage elongation is increases. Carbon content in metal in the steel, suppose carbon percentage is increases, then ductility of that specimen is decreases, and suppose high carbon content is there, then steel becomes brittle and you get fracture, brittle fracture instead of the. Now, mechanical properties obtained from different destructive testing, and as we seen in this video tensile test, so mechanical properties obtained from the tensile test are tensile strength, yield point, elastic limit, ductility, toughness, ultimate tensile strength, breaking strength, etc. And uh, obtaining these details, we can develop or research on that material or metal, and we can give the proper properties, mechanical properties of that sample specimen. So this is the tensile test. Thank you for the listening.